real missions, whether in a jungle at night or in orbit around the moon. Live or die on logistics, not on speeches or hero shots. That is the unromantic truth running under both the story of a small recon team surrounded by hundreds of enemy soldiers and the story of a crew trying to stay alive in a thin metal can 250,000 miles from home. In both situations, the people who walk away are not necessarily the bravest or the loudest. They are the ones whose plans respected every boring constraint that reality could throw at them. Picture a ridge in Southeast Asia, blacked out, humid, and silent except for insects and the soft creak of web gear. A handful of MACV-SOG operators and their Vietnamese partners lie in a tight circle, close enough to touch each other in the dark. Somewhere out there, several hundred enemy troops are moving up and down the ridgeline, closing in like a vice. The team has one thing in their favor besides training and nerve: their preparation and their discipline around noise, timing, and communication. When someone walks inside the perimeter, they do not panic and spray bullets. They follow an agreed rule. Once you go down at night, you do not get back up. Anyone moving is a problem to solve quietly. Now jump forward in your head to a future lunar ridge. Gray dust instead of jungle soil, vacuum instead of thick air. A small crew inside a habitat listens to telemetry instead of snapping twigs. Around them, invisible fields of radiation and micrometeorites. Hard vacuum and brutal temperature swings are doing the same thing that jungle did to that recon team: squeezing options. The crew's survival depends less on their ability to give stirring quotes into a camera and more on how many spare filters someone insisted on manifesting 6 months earlier when the cargo list looked too heavy. In war, the quiet guy carrying the heavy crypto radio and spare batteries is keeping everyone connected to artillery, air, and rescue. That KY safe set, or its modern equivalent, is awkward, sweaty, and miserable to carry. Yet when the perimeter starts to close, it becomes the most important piece of gear in the team. In space, the same thing is true of ugly subsystems like communications redundancy, power storage, and propellant management. No one prints posters of a cryogenic valve, but if it fails at the wrong time, the mission becomes a long obituary read on some distant channel. The famous story of that jungle team hearing their own names read out as dead over a supposedly secure radio is a perfect illustration of how logistics and security failures cascade. Somewhere, someone let codes leak, or hardware get captured, or spies sit in the wrong room. 8 days of delay on the launch site gave the enemy time to gather intelligence, reposition, and build a trap. By the time the team was back on mission, the battlefield had quietly rearranged itself against them. Space is not kind to that kind of sloppiness either. If you slip a launch window by a week, the positions of the Earth, the Moon, and the Sun change. Your fuel margins shift, your thermal environment and lighting change, and sometimes an entire transfer solution disappears. Space agencies like NASA and ESA now plan lunar and Cislunar campaigns with this same grim honesty. They do not ask, what would look coolest in a trailer? They ask, how many tons per year can we reliably deliver to this orbit, with what on orbit boil off, and what cadence can budgets and factories sustain? If a lunar lander needs tens of tons of propellant in a high orbit to go down and back safely, that mass has to arrive in chunks, launched by tankers that themselves have maintenance cycles, weather constraints, and crew limits on the ground. A depot that slowly loses hydrogen while waiting on a delayed launch is the orbital equivalent of that recon team listening to 800 men close in while the radio crackles with the wrong voice. This is why the boring phrase mass to orbit quietly rules everything. Every kilogram of water, all oxygen, shielding, spare parts, and food you want on the moon first has to be thrown uphill, accelerated through Earth's gravity well by real engines burning real propellant. The rocket equation does not care how badly you want to base. It only cares about exhaust velocity, mass ratio, and delta V. Mission designers live in that math. If you want a permanent presence instead of a flag and a photo, then one spectacular rocket flight every 10 years is meaningless. What matters is whether you can push cargo and people up that hill on a regular drumbeat for decades. The jungle team understood cadence in their own way. They moved at night and slept in short, disciplined shifts. They set claymores and listening posts according to a routine, not a mood. Every time they stopped, someone took sector responsibility without being told. That quiet repetition, that refusal to improvise the basics, kept them alive long enough for air assets to reach them when things went sideways. In a modern mission control room, the same principle holds. Checklists, shift handovers, and never skipping a simulation just because everyone is tired are the difference between a tough day and a tragedy. Look at the moon itself and the constraints get even uglier. The regolith is not soft beach sand. It is the ground-up remains of rock, hammered by impacts for billions of years, full of jagged dust that clings electrostatically and chews through seals and lungs. Apollo crews came back into their landers coated in that stuff, reporting the sharp smell and how it irritated their noses and eyes. A future base will need airlocks, filters, suit ports, and cleaning procedures bordering on obsession. Every one of those items has weight, failure modes, and maintenance cycles. Cut too many of them from your manifest to save mass for something flashier, and you are choosing slower, messier deaths later. Radiation is equally unforgiving. Beyond Earth's magnetic field, high-energy particles hammer bodies and electronics. Engineers respond with shielding strategies like water walls, storm shelters, and clever trajectories that dip behind fields when possible. Those decisions are made years before any astronaut straps in, and they show up on paper as extra kilograms of water or polyethylene. In a budget review, someone always wants to shave that mass. In a crisis, everyone is suddenly glad it is there. Orbit mechanics adds another invisible cage. Between Earth and Moon, communications lag is only a couple of seconds, but that is long enough to force crews to act without immediate coaching. Guidance systems, autonomy algorithms, and very human training for talk, then do, then report are all logistics choices made by training departments and software teams, not by the camera-facing spokesperson. On a Mars transfer with many minutes of delay, that autonomy becomes even more critical. You either invest upfront in systems and people who can function without constant feedback, or you plan to read a lot of obituaries later. There is a direct parallel in ordinary life that is almost too neat. Most people think in terms of big dramatic moments. Quitting a job, moving cities, starting a company. In reality, the thing that decides whether any of those moves work is the unglamorous logistics behind them. Do you actually sleep enough to think clearly? Or are you running your brain like a badly maintained engine at redline? Do you have a modest savings buffer so that one surprise bill does not collapse your orbit? Do you have 2 or 3 people you can trust with bad news, the way that recon leader trusted his radio operator? Or are you effectively alone inside your perimeter? If you pay attention, you will notice how many modern problems are really supply chain issues wearing emotional costumes. The constant low-grade anxiety a lot of people feel is often just the feeling of running with no margins. Every day is launched with no delta V left for contingencies. Every social feed is a noisy radio channel where strangers read off your supposed failures. Every new commitment is another platoon closing in on your limited attention and time. The MACV-SOG story about hearing a stranger calmly listing the team as already dead over a secure frequency is surreal, but it translates almost perfectly into the way digital life often feels. Somewhere out there, algorithms and opinion cycles are rehearsing your failure before you even act. If you let that phantom voice set your priorities, you will start planning as if you are already finished. Missions in space cannot afford that mindset. They plan as if they will succeed, but with a detailed map of every way they could fail and a stack of mitigations ready. Space agencies handle this by formal risk matrices. They list hazards, estimate likelihood and severity, assign mitigations, and then revisit all of it as new data arrives. Nothing mystical, just disciplined humility in the face of a hostile environment. The loudest voice in the room does not get to override the chart without evidence. That same posture works brutally well at human scale. Write down what could realistically go wrong in your life over the next year, what you would do, and what small redundancies you can build now. It is not pessimism. It is respecting the physics of your own situation. Commerce adds another layer. The rockets sending cargo to space are built in factories that rely on mined metals, refined fuels, computer chips, trained welders, and shipping networks. A pandemic, a war, or a port closure ripples up that chain in delayed launch dates and busted budgets. No one gets to pretend they are operating in a vacuum, not even in literal vacuum. The more ambitious the mission, the more its success depends on a thick, boring, terrestrial tangle of contracts and maintenance schedules being honored over and over again. That may sound bleak, but there is something oddly calming about it. If outcomes depend so heavily on logistics, then you are freed from chasing the illusion that you only need the right inspirational slogan or mystical mindset. You can focus instead on building systems that do not care how you feel on a particular Tuesday. Checklists do not get offended. Stored water does not talk back. Extra sleep does not require your timeline's approval. Even that jungle team, pinned on a ridge with hundreds of enemies above and below, did not survive solely because they were tough. They survived because someone had decided how many machine guns they would carry, how many claymores to pack, how to spread security in a perimeter, and what the rule of engagement at night would be. They still bled, they still almost died, but they gave physics and probability fewer easy chances to kill them. Modern crews in orbit or on the moon will be in the same position, floating on a thin raft of engineering choices made years earlier by people they will never meet. Seeing the world this way is not glamorous, but it is accurate. Whether you are planning a lunar depot or trying to build a life that does not collapse every time something unexpected happens, the questions are similar. What are your actual constraints? Where is your mass budget really going? How often can you reliably launch effort into the things that matter? How much margin do you have for failure before you cannot recover? The more honest you are about those questions, the less you will have in common with a name on a premature obituary, and the more you will resemble the quiet, unphotogenic machinery that keeps missions going long after the crowd has stopped paying attention. In the end, logistics is simply respect for reality, applied every day without comforting drama.
6 and Palapa B.
Less dramatic than space, but this is where the damage timeline of the mission is patiently
STS-50